everybody, I'm Paul. I'm a co-founder at Drifting in Space. We do things that have to do with multiplayer, so this is not too much out of my wheelhouse, but the gist of what we do is when applications want to exceed, browser-based applications want to exceed the performance ceiling of the browser, we have infrastructure for that. Turns out that a lot of applications that want to exceed the browser performance also want to do multiplayer, because multiplayer is cool these days. When I talk about multiplayer, this is kind of an example of what I'm talking about. This is a demo that we built with some of the techniques that I'm going to be talking about in this presentation. Depending on your point of view, this is either low-budget Minecraft or metaverse that actually works. So this is, yeah, basically this is three of us in this shared 3D world. It's React 3 Fiber happens to be the framework we use for this. And then the multiplayer is, well, we'll talk about. But yeah, this is under 250 lines of code, which is, I think really says a lot about React 3 Fiber as well. But only a few dozen of those lines are actually the multiplayer. So one of the things that I really want to drive home tonight is that multiplayer, if you Google it, like if you look into what people are talking about, there's CRDTs, you go down these rabbit holes, but it doesn't have to be complicated. But the first piece of complexity kind of creeps in when we realize that browsers can't talk to other browsers, or an application running in a browser can't talk to another application running in a browser, at least not without WebRTC and some other fancy stuff. So generally, we don't have this assumption that we can just talk to a peer and transfer state. What we can do is spin up a server that both parties can talk to. So each instance of your application can open a WebSocket connection to a server that you're running somewhere. And you can kind of treat that like it is connected. Like from each client's point of view, it's like they have a WebSocket connection to the other client. So this is just assuming that this server is basically just a dumb relay. It's just taking a message, sending it to the other client, getting a message back, sending it to the other client, and sending them back and forth. And we can generalize that to multiple clients. So multiple clients can sort of all connect to the same server. And you can almost imagine it like a group chat. Like all of these applications are kind of in this group chat together. They send out messages. They receive messages. And they have this kind of log of message history. And when I'm talking about these group chats, each server can kind of host multiple of these. So each one you can kind of think of as a room. You can kind of think of it as a chat room in the group chat analogy. But they operate independently. So each set of clients who's interested in the same document state, program state, game state, the same things in general, they can talk to one room, be in one group chat. They can share that server with another group chat, but there's no overlap of who's talking to who. You can also split that room across servers. Have multiple rooms that are on different servers. What you can't do is have clients talking to different servers. And that's really where things can get complicated. This is from a blog post that Figma did a while back on their architecture for multiplayer. One of the things that's notable about it is that even back, this is a few years old now, they were doing this kind of routing where if you're using one document and I'm using the same document, we're ultimately talking to the same server. So our connections might be to different IPs. They might be going through some routing on Figma's end, but ultimately, we are talking to the same process on the same server. So one of the things that we've done at Drifting in Space is we've kind of generalized that architecture. So we have an open source project called Plane that you can kind of deploy that type of infrastructure on your own machines. But what we realized is that a lot of people wanted to use Plane for things that were really just these kind of group chats, like just these kind of message passing types of applications. So we kind of went back to the drawing board and looked at what we would build if that was the problem we were trying to solve for exclusively. So now we've come up with this thing called DriftDB. We open sourced it a few months back. We've had some really good reception on it. And so it basically is that group chat server. So it's hosted on Cloudflare. So it's built to be multi-cloud and multi-platform. It just turns out that Cloudflare has the most robust platform for this type of thing on the edge. So we've totally embraced the edge compute aspect of this. And so an example of why that matters is if you're just using this server backends to kind of create these connections between a small number of people, you don't really want those packets to have to cross the Atlantic to go to a central server or anything like that. So taking advantage of Cloudflare's edge network, what we can do is spin up these servers close to the users so that they're as low latency as possible. So that's DriftDB. That's kind of the thing that we built. That has nothing to do with React yet. It's basically this group chat pattern for your application, where your application can kind of open a WebSocket connection, talk to other users who are in the same room. The infrastructure is taken care of mostly by Cloudflare, actually, not really DriftDB. But one of the things we wanted to do with that is build ergonomic React hooks to kind of see how far we could push the developer experience so that we could really make these types of multiplayer things less complicated. Because when I looked at a lot of the other multiplayer kind of off-the-shelf things that you can do, my mind would just melt, and I would just be like, why can't I just use setState? So you've probably all seen setState, so I don't really need to go into like what setState is, but this is just an example of a controlled component, a slider. We're calling setState. This has nothing to do with multiplayer yet. This is the multiplayer version. So what we've done is we've imported useSharedState from DriftDB-React. This is our React binding library for DriftDB. And then we just changed useState to useSharedState. And then we had to add this little key. So this is saying within the room we're in, and I'll get into how we've connected to the room in a minute. But within the room, we need to kind of attach to some value. You can kind of think of it like DriftDB here is acting like a key value store. So we're kind of attaching this slider to the slider key. This can really be any string you want as long as every instance of your application is using the same one. If you wanted to have multiple sliders, you could pass that in as a prop, and then you kind of have multiple sliders interacting with other sliders. It's your application, do whatever you want. So yeah, this is kind of the important line here is this useSharedState. I should have highlighted that earlier. Here's a quick demo. This is actually a demo of the code you saw in Replit. So I just kind of copied and pasted that code in. Replit actually hosts your site, which is kind of cool. So you get like this URL, so you can open it up side by side. And even though this is, obviously this is the same machine I'm recording screen next to screen, but it really is going to the edge when I move the cursor. It's going to the nearest Cloudflare edge server and doing that. There's some limitations of doing something this naive. There are two big ones, really. Race conditions are one, and I'll show you an example of what that looks like. The other one is that we're frequently sending the entire state. So if the entire state is like an integer between 1 and 100, as it is for a slider, nobody cares. But if the entire state is a Figma document or a voxel like world or something like that, you run into trouble. You're choking the network. So that's not great. So here's kind of like a network diagram of what I mean by race conditions. So initially, we have an empty list. The server's sending this empty list to both parties. Bob pushes to the list. And we're just, like I'm using a list of numbers for compactness, but you can imagine this being like a to-do list. And Bob is adding his to-do. Or maybe it's a grocery list, because that makes more sense to share with two people. So Bob is adding cheese, and Alice is adding bread. So they're both pushing to the list, but when they push, they're just modifying their local version of the state and then sending it to the server. The server gets Bob's state and is rebroadcasting. And remember, this is like a group chat, so everybody gets every message, even the messages they sent. And this is the problem here. So Alice pushes before she has Bob's state. So she's pushing on what she thinks is an empty list. But that's if she had all the state, it's not an empty list. So her change is actually overwriting Bob's, or it's erasing Bob's. And it's really just a matter of luck or a matter of timing for her that, for Bob, really. Bob's the one who missed out. So it's a matter of timing for him that he just happened to add that at the wrong time that it got overwritten. So this doesn't work. We can actually solve this without leaving this kind of nice world of React state management idioms and hooks and things like that. So we can still have an analogy to a React hook. It is a bit more of an obscure hook. Some of you may have used it. But actually, by show of hands, who's used useReducer? OK, so yeah, it's about half the room, third of the room. So it's not that obscure. It's also Redux, I guess, was where I first encountered reducers, and I think React kind of just picked that up. So this is sort of an example of what this could look like with useSharedReducer. So just as we have useSharedState for useState, we have useSharedReducer for useReducer. We define an action type. Since this is TypeScript, I like to write out what the interface looks like. Basically, we're managing a list, so we have push and pop. I didn't go all out on the list management features, but the important thing here is, well, first of all, that we're operating on a copy of the data, on the copy of the state, which is just a hook React reducer kind of assumption. We implement the action, return the new state. So another kind of phrase for this or term for this, especially in the context of multiplayer, is state machine synchronization. And then to use this, we kind of use it like useReducer. We get a state and a dispatch function. So the dispatch function takes an instance of our action. So we can, for example, push 5. So to run through what this looks like now, we have the empty list. We have a confirmed state and an optimistic state. So the optimistic state is the state with the local changes applied before we hear it back from the server. And that just allows UI to kind of feel instantaneous. We actually do this on the state side as well. I just didn't show it in the diagram. So Bob pushes 5. Alice pushes 8. Bob's change is rebroadcast. Both sides now have the confirmed state of 5. This actually, depending on the implementation, but we'll say it overwrites the optimistic state on Alice's end. The server then rebroadcasts Alice's change, and now both sides have the same state. So in both cases, both the broken one and the fixed one, this confirmed state was consistent among both. So this wasn't a consistency or a correctness problem. It was basically a problem of our intent. We intended for Bob's change to persist, and it didn't. I guess you could argue that is a correctness problem, but I'm going to share another quick demo of this. This is a counter. This is like the common reducer demo. This is actually based on React's docs for useReducer. So we just import it. We've got our count function. If action is increment, we increase. If it's dec, we decrease. Yeah, you've seen all this. We're going to add some buttons and a span. And so this demo looks like this. Very basic, but you can see we've done this. And it's hard for me to demo on one machine, but there's no race conditions here. It's all resolved. To the question kind of like, what about where these rooms come from? Is everybody always in the same room? The answer to that is we have this provider called a DriftDB provider. So this uses React's context. When you wrap some code in this DriftDB provider, everything within that is able to use a useDatabase hook to get a connection to the DriftDB database and is able to then create subscriptions and things like that. What the provider does is You can pass it in a room ID. So if server side you want to figure out some room ID and do your kind of rooming that way, maybe somebody opened a document and you want to stick them in a room or whatever, you can do that. But to make things very easy to get started with, what this does is if it finds a room ID in the URL, it'll connect to that room ID. And if it doesn't, it will connect to the server. This is like the local dev server that we ship. It can connect to the dev server, ask for a new room, and then take it back and stick it in the URL bar. So then if you share that URL, somebody else is in the same room. We also have a hosted instance of this. So you can actually go to gemsocket.live, you put in your email, you get a key that looks like this. And you can expose that in client-side code. It's not like a secret key or anything like that. But that allows your client-side code to spin up these instances. You can use it in development as well. Yeah, it's hosted on Cloudflare. But again, it's all open source. You could actually take the code that we're running on Cloudflare and run it on your own Cloudflare account if you wanted. Or you could take our dev server and turn it into something that you could run off of Cloudflare. So I've got a few quick demos here. Oh, I need to, let's see. OK, this works. OK, so the first one is, this is state sharing. What I'll do is pull it up here. So this is basically the use shared state style state sharing. So this is just a few components that I've hooked up here. And yeah, someone else joined. So yeah, you can see multiple people can join. And it's kind of hard to see. We make it kind of faint on purpose, but we can see the latency here. I can actually click in and look at a UI to kind of see the messages going back and forth. I'm going to redo this UI shortly, so I don't want to dwell too much on it. So that's that one. This is similar to the counter demo that I showed. So this one is, maybe someone will beat me to connecting to this one. But yeah, you can count. The nice thing about this kind of state machine synchronization model is you can do things like turn-based games very easily. The turn-based game ends up being basically like this is a reducer function. The entire game of tic-tac-toe is written in this reducer. Each click to the game sends that, I'm trying to play here, and this is who I am. And the reducer will say, OK, you're the right person. It's your turn, or it's not, and update the board accordingly. I shouldn't have added a reset button. Another one I want to show here. So I mentioned early on, like, you can't connect directly from one browser to another, which ends up being like mostly true. But there is WebRTC, where we can go and so in this case, these two browsers are talking to each other directly. And so you can see, yeah, WebRTC latency, 0 milliseconds. So that's because WebRTC is able to kind of figure out the closest path between the browsers. If they're on the same network, that's like the router, or it might even be loopback. So you can actually get 0 latency. In practice, you have, if there's two different people, even on the same network but different machines, there's probably going to be a little bit of latency. But you can see, and then we've kind of estimated the latency here of going through the cloud. Usually, I find this Wi-Fi adds a little bit of, guest network adds a little bit of latency here. Usually, we see latency under 100 milliseconds. And then we have our shared canvas here. I don't think this one's going to work well on mobile for you guys, but you can kind of, this is like, so you can draw squares and move them. So it's basically Figma. Where's our 20 billion? So yeah, so that is that. And if I go back here. yeah, that's all from me. So I have my Twitter, our company Twitter. Feel free to email me. I do a newsletter about browser tech, so like WebGL and WebAssembly and stuff. Slides and also links are on that QR code. And that's all from me. Thank you.